Hey guys, I'm Dasha. Today we'll learn about modules, how to calculate them, and perform operations like comparisons, multiplication, or addition between two modules. To understand modules, let's first look at opposite numbers. For instance, 2 and negative 2 are opposites, right? 3/5 and negative 3/5 are also opposites. This applies to both whole numbers and fractions, like 0.5 and -0.5, comma, which are fractions but still opposites. But they're opposite numbers. How do they differ? They're kind of similar. If you ignore the minus sign, they look the same, right? A module is the absolute value that unites these opposite numbers. You probably know to show a number's module, use two vertical lines. So, the modulus of both positive and negative numbers is the same, as it's an absolute value, always non-negative. But we can't say it's always positive. Why not? Because it includes 0. For instance, 0 and -0 have a modulus of 0, though we don't usually write it that way. 0 isn't positive or negative, so the modulus is always non-negative, not strictly positive. In this case, for example, it would be 0.5. If we put the modulus here, it'll be 3/5. If here, then 2. Let's calculate these moduli. We have decimals, fractions, integers, and both negative and positive numbers here. Let's break it down. Say, here's -2. What's its modulus? 2. Because we simply remove the minus sign. That's it. It's straightforward. The modulus of a positive number is that same positive number. 15 minus 8, 37. What's the result? 37 minus 2/5. 2/5. 0.1. So it'll be 0.1. Here we just subtract 5.36. We rewrite it as 1.58. Remember, for 0 and positive numbers, it stays the same. So 37 and 15 remain unchanged. We don't alter anything. For negative numbers, remove the minus sign. Let's solve 4 comparison examples. Which is larger, absolute value of -5/7 or 2/7? What's the answer here? It's 5/7, a positive number. So it's larger as 5 is greater than 2. What do we have here? 3/11 and 3/4. Let's find a common denominator. Multiply this by 11 and this by 4. We get 12/44 and 33/44. Which numerator is larger? This one or that one? This one, that's right, 33. It doesn't matter if the numbers inside the module are positive or negative. In this case, what do we have? 900ths. Right? 900ths. Because we simply discard the minus. But here we need to convert this fraction to decimal. That's 0.09. Or we could say 900ths. It's the same thing, but essentially it's equal. And 0.3. So let's look at this. Here we'll have 2/5, right? Because we simply discard the minus. Here we have a decimal fraction and here an ordinary fraction. Let's see, 3/10, yes, 3/10. Let's multiply this part by 2 as we'll get 10 in the denominator. By 2, right? 4. Here 2 times 2 is 4 and here it's 10. So we get 3/10 and 4/10, which is more. So 0.3 is less than the module of -2/5. This is quite advanced for this module topic on calculations. Let's try to calculate. I'm sure you'll manage just fine. If you want, pause and write your solutions for these 4 examples in the comments. So what's the module of 8? 8, yes, because it's the same number, plus the module of -5. We discard the minus, so it's just 5. It's 13. What's the module of -15? We drop the minus. 15. Minus module of 12 is 12. What's the result? 3, right? 15 minus 12 is 3. Modulo of minus 8. 8 times 10. Same thing, right? We dropped minus here, wrote it there. It's 80. 8 times 10 is 80. Positive number here, we write 15 divided by module of minus 3, dropping minus 3. 15 divided by 3 is 5. If modules seem less scary now, hit like. Hope everything's clear now. Best wishes to all. Bye-bye.